Alright, so we're on to tutorial number 3. The first question here is rationalize the denominator. Okay, we've done lots of those already in the first two tutorials, so let's go through them. First question, we've got 3 minus square root of 6 divided by 6 plus the square root of 12. So we said many ways we can do it. We can first simplify the roots if we like, but in the end we know we have to multiply by the conjugate of the denominator. So we're going to multiply by 6 minus root 12 over 6 minus root 12. And the reason for this is that the bottom, the denominators, the squares and the square roots in the denominator will cancel out. So at the top we just multiply this by this. So that will give us 3 times 6 is 18. 3 times negative root 12 is negative 3 root 12. Minus 6 root 6. And then plus root 6 root 12. Okay, at the bottom we've got 6 times 6 is 36. These will cancel out the middle terms. We've got minus 6 root 12 plus 6 root 12, which will cancel out. And then at the end, we've got root 12 times negative root 12, so the roots will cancel out, and that'll just give us that. So at the top, let's simplify our roots a little bit. So we can keep the 18. 12 is the same as 2 root 3. Root 12 is the same as 2 root 3. Root 6 we can't simplify any further, so we can keep it like that. And then root 6 times root 12, we can write as root 72. Okay, so again, I'm doing lots of steps here just to show what we're doing. The bottom 36 minus 12 is 24. Okay, so now here the negative 3 times 2 we can multiply, and that'll give us negative 6 root 2 minus 6 root 6. And then square root of 72 we can simplify into, what is that, 9 root 2. Let me just check that. So the square root of 72 we can rewrite as the square root of 2 cubed times 3 squared. So we can take out 2 times 3 is 6 root 2, sorry, not 9 root 2, my bad, I made a mistake. So that's 6 root 2. Okay, well that's quite nice, because now I've got 6 root 2 negative 6 root 2 plus 6 root 2, so those can cancel out. At the bottom we've still got our 24, and we've got these two will cancel out. Then we've got 18 minus 6 root 6 over 24. We can factor out a 6 at the top, which leaves us with 3 minus root 6 over 24. And then finally we can simplify the 6 over 24 to just become 3 minus root 6 over, and then 24 divided by 6 is 4. And that's our answer. Okay, so again, I did lots of steps here. And I'm not sure if you're allowed to use a calculator while doing this or not, but it's good to just get a grasp of how to go through the steps without a calculator, which will make it a lot simpler to do when you actually do use a calculator, so that you at least know exactly what you're doing. Okay, especially if they start adding some letters like here, then it makes sense to be able to do it without a calculator. Okay, question B, we've got square root of a plus 1. Square root of a plus 1 over square root of a plus 1 minus square root of a over the square root of a plus 1 minus the square root of a. So the same thing, we'll multiply by the conjugate of the bottom over itself. So we'll do square root of a plus 1 plus square root of a over square root of a plus 1 plus the square root of a. And again we just do the multiplication. So at the top we multiply this by this. So multiplying these two, the square root will just cancel it out, and we've got a plus 1. And then square root of a plus 1 times the square root of a just becomes plus the square root of a plus 1 times the square root of a. At the bottom here, if we multiply this by this, it just becomes a plus 1. And then we know again the middle terms will cancel out, and we'll just be left with negative a. Negative a. Because square root a times square root a is just a, and it's a negative. Okay, let's see if we can simplify this a bit. So at the bottom, we'll obviously have a minus a, which will cancel out. The bottom will just have 1, so the denominator actually just falls away. Now at the top, we probably can't do much, but let's just see. So what we can do is, if we have a square root times a square root, we can multiply those together. So we can have the square root of a times a plus 1, and that'll give us a plus 1 plus the square root of, if we multiply this in, we get a squared plus a. So not much we can do here. Doesn't simplify further. So you could even just leave your answer as this. That should be fine. Or as this, or as this. All of them should be fine. Okay, good. That was question B. Question C, 1 minus u squared. Let's do it over here. So 1 minus u squared over square root of 3 plus u plus 2 over the square root of 3 plus u plus 2. Okay, let's again multiply by the conjugate. So we're going to get square root of 3 plus u minus 2 over the square root of 3 plus u minus 2. And again, we just do the multiplication. So multiply those together. So that gives us 1 times the square root will just be the square root. 1 times negative 2 is negative 2. Negative u squared times that will just be negative u squared times that. And then negative u squared times negative 2 is plus 2u squared. At the bottom, we'll again have the first term times the first term, which is just 3 plus u. And then the last term times the last term, which is just negative 4. Okay, next, let's see at the top here. Well, let's do the bottom first. Bottom is easy. 3 minus 4 is negative 1, right? So we just have u minus 1 at the bottom. And let's see at the top. So we could do some grouping here. Some grouping. Okay, so some grouping here. Actually, we're just working the circle, but that's going to be necessary in this case. So you don't always know that, because here there's no like terms we can collect, but we can say let's group together the, what will we group together? Let's group together these two, and let's group together these two. Okay, so from this we can factor the square root of 3 plus u, and what's left is then 1 minus u squared. 1 minus u squared. And then from these, from the red ones, we can factor out minus 2, or let's say plus 2. If we factor, what do we want to factor out here? Yeah, we want to factor out a minus 2, and we're left with 1 minus u squared as well. So we see we just get back to the top part. That's already the factorized part. So that's what we mean by working in a circle, which is not exactly what we want to do in general, but you don't always know if you need to get back to what you started with or not. Okay, so this gives us at the top the 1 minus u squared times the square root 3 plus u minus 2. The bottom we've got u minus 1. So now, from here, from this first one, we can say that's just the same as 1 plus u, 1 minus u. And then square root 3 plus u minus 2 all over u minus 1. So now we can see these two brackets look pretty similar, but they're not exactly the same. So what we can do is we can factor out a negative 1 from this one. So let's just continue over here. So we'll keep the first bracket, the 1 plus u. Then we'll factor out a negative from here. So if we take out a negative, let's just put that in the front. Then the signs will change. So now it's going to be a negative 1 and a positive u. So a negative 1 and a positive u. And our third bracket just remains the same. Square root of 3 plus u minus 2 all over u minus 1. And now we see we can cancel out these two. So our final answer would just be negative 1 plus u, and then the square root of 3 plus u minus 2. And that will be the simplest form, I believe. Alright, question 2. So for question 2, we have, what do we have here? Perform long division. Okay, so we've already done some of those as well, but let's get into it again. So x to the power, that's number a1. Okay, a1. We've got x to the power 6 plus 2x to the power 4. So I'm just going to plot 0x to the power 5 here, because we don't want to miss any of the exponents. We want to get all the way descending down to 0. So plus 2x to the power 4. Then no x cubes, so we're going to put 0x cubed. X squared, yes, there's a minus 4x squared. There's an x, and then there's a constant 2. Alright, so we've got all of that, and we want to divide that by x to the power 3 plus 3x minus 4. Okay, so we start by taking this first value here, dividing it by this first value here. So x to the power 6 divided by x to the power 3 is x to the power 3. And then we take this x to the power 3, first part of our quotient, and multiply it by the whole of the divisor. So x to the power 3 times x to the power 3 is x to the power 6. Then x to the power 3 times 3x squared is going to be 3x to the power 4. Then x to the power 3 times negative 4 is minus 4x to the power 4. Okay, and then we want to subtract this, what we got here. So that minus that is 0. 0 minus 3, that's a 5 here, sorry. 0 minus 3 is negative 3x to the power 5. And then 2 minus minus 4 will give us 6x to the power 4. And then let's bring down the next value. So plus 0x to the power 3. Now let's divide again. So we start the same process all over, and we just keep repeating. So take this first value here, divided by this first value here. So negative 3x to the power 5 divided by x to the power 3 is negative 3x to the power 2. Then again we take this value and multiply it by the whole of the divisor. So negative 3x squared times x cubed is negative 3x to the power 5. Negative 3x squared times 3x is negative 9x to the power 4. Sorry, I'm lying here. I'm lying. Sorry. I'll make a note of this in the video. I did this wrong. Let's get rid of all of this. I made a mistake. Did not focus. Okay. So let's start again. So this part is correct. Now we multiply. So x cubed times x cubed is x to the power 6. X cubed times 3x is 4x squared. So we want to put that underneath the x squared. 3x squared. So we want to put that underneath the x to the power 4 part, right? X to the power 3 times x to the power 4. So we want to put that there. So there's no x to the power 5s that we had here. And then x cubed times negative 4x is negative 4x cubed. So that's why we actually put in all the different exponents so we can put them on their correct spots. So it's easier to see. Okay, this minus this is nothing. The x to the power 5s, nothing there. X to the power 4s, we've got 2 minus 3, which is negative 1, x to the power 4. Then x to the power 3s, we've got 0 plus 4, which is 4 x to the power 3. And then we can just bring down the rest. So minus 4x squared plus x plus 2. Okay, now we start the process again. Take the first term here, divided by this first value here. The negative x to the power 4 divided by x to the power 3 is negative x. Then we multiply this back in. So negative x times x to the power 3 is negative x to the power 4. Negative x times 3x is negative x squared. So put that underneath the x squared. We've got 0x cubed. And then negative x times negative 4 is positive 4x. Okay, and we subtract this. So that minus that is nothing. 4x cubed minus 0x cubed is still 4x cubed. Then we've got yeah, okay, that's fine. Then we've got negative 4x squared plus x squared is negative 3x squared. Then we've got x minus 4x is negative 3x. And then we still got our plus 2 here at the end. Okay, and again, we repeat the process. This can still be divided because it still has the same or larger exponent than the first value. So 4x cubed divided by x cubed is 4. And then we multiply the 4 back in. So that gives us 4x cubed. 4 times 3x is 12x. So that has to go underneath the x's. And then 4 times negative 4 is negative 16. So we have 0x squareds. And we subtract. That's nothing. Then negative 3 minus nothing is negative 3x squared. Negative 3x minus 12x is negative 15x. And then 2 minus minus 16 is 18. Okay, now we can't divide any further because we see this exponent here is smaller than this exponent here. So we're done. This is our remainder. Okay, that is our first question done. Next we have to AI. Okay, the second question, the 6x to the power 4. Yeah, performing long division. Actually, I wanted to see if we can't factorize that. But let's do the long method like this first. Okay, minus 30x squared. So we've got 0x cubed. We've got minus 30x squared. We've got no x's, so 0x. And then we've got 24. Okay, just make that into a proper 2. And we want to divide that by 2x squared minus 8. So by 2x squared minus 8. Okay, so let's do the division. Like I said, you could simplify this a little bit first and then do the division, which I think is a good idea. But let's do it just straight as they gave it to us. Okay, so again, first value divided by the first value. So 6x to the power 4 divided by 2x squared will be 3x squared. Multiply the 3x squared back with the whole divisor. That gives us 6x to the power 4. And then 3x squared times negative 8 is negative 24x squared. Negative 24x squared. 0x to the power 3s. Then we want to subtract that. That's nothing. 0 minus 0 is nothing. Negative 30 plus 24 is going to be negative 6x squared. And then let's bring down the rest of our values. Plus 24. Okay, now we repeat the process. So negative 6x squared divided by 2x squared is going to be negative 3. Multiply the negative 3 back in. So negative 3 times 2x squared is negative 6x squared. Negative 3 times negative 8 is positive 24. And we've got 0 x's. So we subtract that, and that just gives us nothing. 0 if we subtract it. So then that is our answer. Good. Then we've got a third one here. So the third one, we have 6x squared minus x minus 15. Okay, so 6x squared minus x minus 15 divided by 2x plus 3. 2x plus 3. Again, let's just do it straight. So, because they do say perform long division, you could also try to factorize and see that you get the same answers if you factorize that. That should be good to see. Okay, equals, not equals, sorry. So 6x squared divided by 2x will be 3x. Multiply that back in, we get 6x squared plus 9x. So we subtract that. That's nothing. Negative x minus 9x is negative 10x. And bring down the minus 15. So again, we repeat the process. Negative 10x divided by 2 is negative 5. Negative 5 times 2x is negative 10x. Negative 5 times 3 is negative 15. And we subtract, which gives us 0. And that is our answer there. Okay, so if you think I made a mistake anywhere here, maybe in the first question that it did seem like an ugly answer, but that's fine if it is. Let me know if you found a mistake that I made in here somewhere. I'm not sure if I did this correctly, especially after the first error that we encountered over here. Okay, so that was question 2A. Then 2B. I'm going to start that on a new page because that's a lot of extra stuff to do there. For question 2B. So the first question, we have to factorize x to the power 4 plus 2x squared plus 9. Okay, so this one is interesting because we cannot find a linear factor for this. The reason for that is usually you check all the numbers in front. So 1 and 9, you multiply them, you get 9. Try all the factors of 9. So that's going to be 1, 3, and 9. And even if we use the negative values for all of them, we still, if we substitute any of these values into our equation, we will not get 0. It's impossible to get 0 from just putting in a number. Because something to an even power, this will always be positive, this will always be positive. So the smallest that this part could be is 0, right? If we take 0 to the power 4. If we take any negative number, the value will be positive again because it's an even power. The smallest that this part can be is 2 times 0, which is also 0, plus 9. So that's the smallest this thing can be, is 9. So it can never be 0, so we cannot have a linear factor. So we can't try the factor theorem to test some values to see which ones work. So what we want to do here is, since we know it's not going to have a linear factor, then what will its factors be? Well, its factors will be quadratics, trinomials. Right, so we're going to have x squared times x squared to give us the first value. And then we're going to have plus, so quadratic has the form ax squared plus bx plus c, right? But we already know a is 1. So these parts we still don't know for the rest. So let's call it plus px plus q. And here let's say plus rs plus rx, sorry, plus rx plus t. So our factors will look something like this. So what we can do is we can just take this and multiply that out, because this must give us that. And then we can equate our coefficients. So let's do that. So multiplying this out gives us x to the power 4 plus rx to the power 3 plus tx squared. Okay, then we've got px cubed, we've got prx squared, and then we've got ptx. And then from the q, so qx squared plus qrx plus qt. Okay, let's collect our like terms. So x to the power 4 is just that, just the x to the power 4. Then the x cubed, we've got this one and this one, so r plus p x cubed. Then for the x squared, so we've got this one and this one. Wait a minute, and this one. Is that right? Let me just make sure I didn't do anything silly here. So px cubed plus prx squared okay, then px squared. Yeah, that looks right. That looks right. Okay. So we've got for this, we've got the x squared, we've got t plus pr plus q. So t plus pr plus q, x squared. Then for the x's, what do we have for x's? So we've got ptx, we've got qrx. That looks like it, right? So plus, so these ones. So pr plus qr, no? pt plus qr. pt plus qrx, and then we've got plus qt at the end. Okay, so I think that's right. Now, we want to compute, or correlate the coefficients with that. So with our two equations, let's change colors here a little bit. So our x to the power 4s, so here we had a 1, here we have a 1. So we've got 1 equals 1, that's obviously true. Then our x to the power 3s, let's change color for each one of these. I think that might be a good idea. Okay, so our x to the power 3s, we've got 0 here, so 0x to the power 3, and here we've got r plus p. So 0 equals r plus p. And that already tells us that we can have p equals negative r. Okay, then let's do the pink ones for the x to the power 2s, the x squared. So here we've got a 2x squared, and here we've got this whole thing squared. So we've got 2 equals t plus pr plus q. Okay, but we already know p is negative r, so we could probably substitute that in. So we've got 2 equals t, and p is negative r, so negative r times r is negative r squared plus q. Okay, so that's simplified a little bit. Then let's do the x to the power 1s, so the x's. So here we've got 0x, so we've got 0 equals, and then our x's here is pt plus qr. So pt plus qr. And again, we know that p is negative r, so we can substitute that to be negative rt plus rq equals 0. Equals 0. Let me just rewrite that. Looks a little bit too much like a 6. Okay, and then our constants, let's do that in black. So our constants, we've got a 9, and here we've got qt. So 9 equals qt. Okay, so now I've got lots of equations that we want to try to solve simultaneously. Okay, so 9 equals qt. So let's actually, before we do anything with the black part here, let's rearrange this, or let's simplify this a little bit further. We can factor out an r. If we factor out an r, we're left with negative t plus q. I'm just going to write it as q minus t equals 0. Once we have that, we know that either r equals 0 or q equals t. So if we know q equals t, we can use that over here. Okay, so q equals t. So 9 equals q times t, and q is t, so it's going to be t squared. So that's going to mean 3 equals t. So plus or minus 3 equals t. And then we know that also means that plus or minus 3 equals q. Okay, so we already have t and q's possible values. And we'll probably just start with the positive values to see how that works out. So we've solved q and t. Then, okay, this part, so r will be 0, I think, it looks like. So in the pink part here, what can we do in the pink part here now? Actually, let's keep it black for these calculations. Oh no, that's fine. Okay, so if we replace q and t with 3's, that's going to be 2 equals 3 minus r squared plus 3. So that's going to be 3 plus 3 is 6. So 2 minus 6 is negative 4 equals negative r squared. And then if we divide by negative, we get that. So we get 2 equals r. Plus or minus 2 equals r. So there we have an r already. Okay, let's do this. Now we've got plenty of things to work with. So p is just equal to negative r. So it's also plus minus 2 then. Because that's just the negative of r. So we've got p, q, r, and t. We've got all our values. So now let's plug them in and see what we get. Okay, so we said it's going to be this, right? So we've got, let me just actually rewrite that down here so we see what we're working with. So x squared plus px plus q, and x squared plus rx plus t. Okay, so plugging in our values, that'll give us in the first bracket then x squared, and let's start with the positives. So plus p, so p is 2, so plus 2x plus q, and q is the same as t, which is 3. Okay, in our other bracket we've got x squared plus rx. Where is r? R is negative p, so r is negative 2 or positive 2. So positive or negative 2. But if we chose p to be 2, let's just do this. So if p equals 2, then r equals negative 2, and the other way around as well. If r equals, or p equals negative 2, then r equals 2, right? Because one is the opposite of the other one. All right. So since we chose p to be positive 2, then r must be negative 2. And then t is the same as q. So let's also do this here. So if t equals 3, then q equals 3. If t equals negative 3, then q equals negative 3. Okay, so t must be the same as q, so it must be plus 3. So that looks like that's our answer. And we can always test this by quickly multiplying this out. So let's do that. So x squared times x squared, x to the power 4. Oops, that looks ugly. X to the power 4 minus 2x cubed. Oops. Plus 3x squared. Then plus 2x cubed minus 4x squared plus 6x, and then plus 3x squared minus 6x, and plus 9. Collect like terms, so we've got x to the power 4. Then the x cubed, so we've got negative 2 plus 2, so they cancel out. Then the x squared, so we've got 3x squared minus 4x squared, so it's negative 1x squared, plus 3x squared will be 2x squared. And then the x's, so 6x minus 6x will cancel out, and then plus 9. So that's correct. Okay, so I hope this made sense. So since we see it cannot have a linear factor, because we can't substitute anything, it'll give us 0. Then we know it's going to be 2 quadratics to give us this. So we just write out the quadratics in their normal form, and then multiply out, and we equate our coefficients. Find some equations and solve them simultaneously. Okay, question B2. I think maybe I'll just finish question 2 for this video, and then we'll get into the rest of the questions in the next one. Okay, so I'm gonna go to the next page and just do the second question here. So here we've got factorize the following completely. So we've got 3x to the power 4 plus 3x cubed minus 3x squared plus 3x minus 6 plus 3x minus 6. Okay, so first of all, we can see there's a common factor of 3. So we can factor out a 3, and then we're left with x to the power 4 plus x to the power 3 minus x squared plus x minus 2. Okay, and now for this polynomial, we can try to find some factors, use the factor theorem to find another factor, a linear factor. Okay, so let's try. So we know it's going to be 1 and 2, so all the factors of 2. So it's going to be 1 or negative 1 or 2 or negative 2. Those are all the options. Let's start with 1. So if we do f of 1, substituting 1 into here, and we're just looking, well, we can look at the 3 as well, but all that's important is this part. So substitute that in. We get 1 to the power 4 plus 1 to the power 3 minus 1 squared plus 1 minus 2. So 1 plus 1 plus 1 is 3, minus 1 minus 2 is minus 3, so that's 0. Good. So that means that x minus 1 is a factor. If you remember that from our first or second tutorial that we did. Right, so if it's f of 1, x minus 1 will be a factor, so you change the sign there. Okay, so far we have then 3, x minus 1, and now we need to figure out what's left if we take out x minus 1 from here. So to do that, we do long division. So we have, actually let's write that over here. So we've got 3, x minus 1, and then something. Now that's something we'll find out now by doing long division. So we're going to have x to the power 4 plus x cubed minus x squared plus x minus 2 divided by this factor x minus 1. Okay, and we just do our long division. So we're not going to go through too many of the steps here. We're just going to do that. X to the power 4 minus x cubed, subtract. So that's going to be 2x cubed. Bring down the next value. Divide again. So that's going to be plus 2x squared. So that's going to give us 2x cubed minus 2x squared. Subtract again. So that gives us negative 1 plus 2 is going to be 1x squared. Bring down the x. Let's divide again. So plus x. That gives us x squared minus x. Subtract. So 1 plus 1 is 2x, and then minus 2. So we divide again. 2x times divided by x is 2. Multiply back in, and we get that. Okay, so this quotient here is what we still have left. X cubed plus 2x squared plus x plus 2. Okay, now we need to again find a factor here that can give us 0. So again, it's going to be 1 and 2. So we're going to try plus or minus 1, and we're going to try plus or minus 2. Let's start with 1. So f of 1, substituting it into this part. So that's going to be 1 cubed plus 2 times 1 squared plus 1 plus 2. Okay, that doesn't work. Obviously, everything's positive, so the positive values won't work here, right? So we don't have to even think about the positives. This is just to show. Then what about f of negative 1? So that's going to give us negative 1 cubed plus 2 times negative 1 squared plus negative 1 plus 2. Okay, so negative 1 cubed is negative 1 plus 2, because negative 1 squared is positive 1, then minus 1 and plus 2. Okay, so that's going to give us 4 minus 2, which is 2. So that's not 0, so this doesn't work. What about f of negative 2? Then we get negative 2 cubed, not squared, cubed, plus 2 times negative 2 squared, plus negative 2 plus 2. Okay, this one is going to work, because here we've got negative 8. Here we've got 4 times 2 is 8. We've got negative 2, and then we've got plus 2. So negative 8 plus 8 is 0, minus 2 is negative 2, plus 2 is 0. So that works, which means that x plus 2 is a factor. X plus 2 is a factor. Okay, so that means that so far we have 3, x minus 1, and then x plus 2 we just found is a factor, and now we need to see what's left. And to do that, again, we'll divide. We'll do long division. You can also do synthetic division. If you were taught synthetic division, it's a little bit quicker than doing the long division. So x cubed plus 2x squared plus x plus 2, we want to divide that by our new factor, which is x plus 2. Okay, let's do the division. So that gives us x squared, x cubed plus 2x squared. Subtract that, gives us 0x squared. Then bring down the next x. So, yeah, is that right? That is right. Okay, so then 0, that's nothing. Let's just do the x divided by x part. So that's 1. And let's multiply that back in. So that gives us x plus 2. Bring down the 2. Subtract. That's 0. And that's then what's left. X squared plus 1. And that is fully factorized, because x squared plus 1 cannot factorize any further. So here we go. That is then our answer. Alright. These are long questions, right? Let's get to the next one. So the third one for question B. 5x to the power of 3 minus 9x squared plus 8x minus 20. Okay, so again, no common factor we can do. So let's again say, so 5, all the factors of 5 and 20 we need to check. So we need to check plus or minus for everything. For plus or minus, factors of 5 are 1 and 5. Factors of 20 are 1, 2, 3, 4, 5, and 20. And 10. Okay, so plus minus all of these. So let's start with the first one. Let's try f of 1. So f of 1, that's going to give us 5 times 1 minus 9 times 1 plus 8 times 1 minus 20. And that is not 0. Okay, let's try f of negative 1. So that's going to give us negative 5 minus 9 minus 8 minus 20. So that's going to obviously not be equal to 0. So we see if we just take negatives, the answer will just be negative all the time. So we do want to choose positive values. So we can ignore the negative part and just choose the positives. And once you've tried a couple of values, you'll see this pattern anyway. And so you don't need to know exactly why this works. Okay, let's try 2. So if we put in 2, we get 5 times 2 cubed minus 9 times 2 squared plus 8 times 2 minus 20. So this gives us 2 cubed is 9 times 5 is 45. 2 squared is 4 times 9 is negative 36. Then we've got, wait, I lied to you, said something wrong. So 2 cubed is 8. 8 times 5 is 40. Minus 4 times 9 is 36. 8 times 2 is 16. And then minus 20. So 40 plus 16 is 56. Minus 56, which is 0. So that means that x minus 2 is a factor. Okay, so then we can divide by x minus 2, because that's a factor. So if we do a division, we get 5x squared. This gives us 5x cubed minus 10x to the power of 3. And that is why Sorry, it's not. That's incorrect. I'm lying again. Okay, so that's going to be 5x minus 10x squared. Okay, let's subtract that. So 0, negative 9 plus 10 is positive 1x squared. Bring down the 8x. Divide again, so we get plus x. It's going to be x squared minus 2x. And then subtract that. So 8x plus 2x is 10x. And then divide by 10x divided by x is plus 10. That gives us 10x minus 20. And that's nothing if we subtract. Okay, again, so far we have x minus 2 times 5x squared plus x plus 10. Okay, and now we need to see, can this factorize any further? Well, no, it cannot. Because it has to be linear factors to get to quadratic. But since all of this is positive, well, it's not all positive, but yeah, since this value will always be bigger than this value, this can't factorize any further. That's pretty much it, because you can't find anything that'll give you a 0 here. You can't find a linear factor, but you can try. So you can see, you can always try all the values. So it's all the factors of 5 and 10. So it's 1, 2, 5, 10. Right, all the factors of 5 and 10, plus or minus, and you can try all of these to see if you get something that gives you 0, but there won't be anything that gives you 0. So that's our final answer. Okay, oh, there's one more. Okay, let's do the last one here for question B. So it's B4. So B4, we've got negative x cubed minus x squared plus x plus 1. Okay, I want to factorize this for you. So here we can actually do grouping. We could probably do grouping with these other ones as well, now that I come to think of it. So let's take out from here a negative x squared. So if we take out a negative x squared there, what's left? X plus 1. And here we can take out nothing. So let's just imagine we take out a 1 just to have some bracket here from these two. So now we can say, okay, this x plus 1 is now a common factor, so we can take that out. And what's left? Well, from this term there's left negative x squared. From this term there's left a positive 1. So that's x plus 1. And let's just rewrite this as 1 minus x squared, just so it looks a bit nicer on the eye. And now we know that's the difference between two squares, so we'll have two brackets. One gets a plus, one gets a minus. Square root of 1 is 1. Square root of x squared is x. And then that's our answer. You could combine these two because they're the same thing. So you could have x plus 1 squared and then 1 minus x. That'll be the same thing, but this should be perfectly fine. Alright, let's leave this video here. I'll continue this video a little bit later, this tutorial, with the rest of the questions. And we're getting into some nicer newer things here in question 5. The first ones are all pretty much the same as the previous tutorials, just a little bit more involved, a little bit longer.